Today we are going to talk about solving logarithmic equations. So just like solving polynomials and rationals, there are three ways that we can solve. We can solve by rearranging, we can solve by factoring, and we can solve by quadratic formula. Now, just like with rationals, we sometimes had to do a little rearranging or some special things that we just do with rationals, like get a common denominator. It's the same thing with logs. Sometimes we might use a log rule. Sometimes we might use something that we know specifically about logs to solve. But essentially, at the end of our solving, we are either rearranging, factoring, or using quadratic formula. So we're going to start with our first question here. It says solve log base 7 of 3x to the 7 minus 41 equals 3. Now you'll notice it says the method we're using is rearranging. So we did talk before about how when we're rearranging, we look to see that we have one term that has a variable. And this only has one term with a variable. So we are going to try to solve by rearranging, which we learned how to do a couple of days ago. So when we are solving by rearranging, we are using reverse order of operations, otherwise known as SAMDEB. And we talked about how logs and trig have the same priority as an exponent. So looking at my expression here, I have a log. We're multiplying by 3. We have a power of 7. We are subtracting 41. And then that equals 3. So first I would try to see if there was a way to relocate our addition and subtraction. The problem is our subtraction is inside the bracket and I can't access the bracket yet. So then I would move on to multiplication and division. Do I have any multiplication or division? Yes, I do. We are multiplying by 3. However, it is also inside that bracket, which is the argument on the log, so I can't access it yet. So that leaves me with, well, the power of 7 is my exponent, and that also is inside that bracket. So the only thing that is not inside that bracket is the log. So we are going to try to eliminate that log base 7, and we do the inverse operation of a log base 7, which we said the other day was a power with a base of 7. So 3x to the 7 minus 41 is going to be 7 to the power of 3. So when I take it to the other side, it still stays the base. It just changes to a power instead of being a log. Okay, we're going to work out 7 to the power of 3. I don't have my calculator with me. I think it is 343. Let me just check on the computer. It is 343. So that is 343. And then to that, I am going to add 41 to both sides. That gives me 384. So 3x to the 7 equals 384. We're going to divide both sides by 3. So that's going to give me x to the 7 equals 384 divided by 3, which is 128. And then I would finish off by doing the 7th root of x to the 7. Now, 7 is an odd number, so I do not need to do a plus or minus here. So we just need to do the 7th root of that, which I believe is 2, but I'm just going to check. It is 2. Now, we mentioned the other day that you do need to check. You don't have to write it down, but you do need to check to make sure that that would work in my original argument, right? What works in my original argument? Well, I can't have a negative and I can't have a 0. So what I would do if I wanted to check, and sometimes I just do this on my calculator, right? All I do is I take the argument and I put in 2, my answer, everywhere I see x. I don't worry about the log. I don't worry about the 3 on the other side. I'm just focusing on the argument. And then I am going to use my calculator on my computer because I don't have my calculator with me. So this is 3 times 2 to the power of 7 and then take away 41, which equals 343. Is that a 0? No. Is that a negative? No, which means we are okay. It doesn't tell me that my answer is correct. It just tells me that my answer would work in the original equation and that it's not part of the restrictions. So I'm going to finish off by just saying that x equals 2. Okay, we are going to try another method, but I think we're going to do that one in the next video. So I'll see you in a minute.